Hello and welcome to video 1.5. So go ahead, get your packet ready, get your notes ready, and we're going to get started. So number 1 says, what is the domain of a function? All right. So the domain is the x values you can put into the function or the input values. All right. And then the range is the y values that come out of a function or the output. All right, so next here, I actually already have these lines graphed out for you. I graphed them on Desmos, screenshotted them, and inserted them into the page. So let's go ahead and look at number 2. It says find the domain and the range of the following functions. For A, we have a linear function. And if we're looking at this line, this goes on forever. I know it doesn't have the little arrows, but we can draw the little arrows on here. All right. And these two, the line will go on in both directions for forever. So if you look, you can see that you're going to be able to plug in all values of x. So you could say that the domain is negative infinity to positive infinity. And we use those little parentheses to indicate whenever we do infinity on an interval, we use the parentheses. Alexa, stop. My Alexa alarm is going off. All right, next one. So now then it asks for the range. So that is the y value. So again, let's look. Well, this line's going to go up and down forever. So the range is also negative infinity to positive infinity. All right, next one. We have our quadratic. So let's see. This quadratic is going to go on forever in both directions. You can see that you can put any number into into this x. You can put any number into there. It's not restricted. So you could say that the domain is again going to be negative infinity to positive infinity. But now let's look at the range. This right here is actually the lowest point. This is called a parabola, and it opens upward. So you're actually not going to get any y values below that point. So your range here is going to be 1 to infinity. Now notice this function actually equals 1. Right? This point is 0, 1, and that's the lowest y value. So we use a closed bracket for the 1 to indicate that the function actually equals 1, and it's going to go off into positive infinity. Next, we have 3x, which is our exponential. So again, let's look at our input values. You are allowed to put in any negative number, any positive number. You can plug in any number into x. So again, our domain, negative infinity to positive infinity. But now let's look at our range. You can see that this function all has output values greater than 0. I know in this picture of it, it almost looks like it equals 0, but that's what we call an asymptote. And the function never touches 0. It gets really, 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 really close to it, but it's never going to touch 0. All right? So, if you think about it like 3 to the negative 1,000, if you plug that in, you're going to be very close to 0, but it's not going to equal 0. All right? So, for the range, we're going to use an open bracket on 0, and it's going to go off into positive infinity because this positive side goes off into positive infinity. Now, the reason it's an open bracket is because there's an asymptote there at 0, and the function never actually touches 0. All right. For number 3, it says examine the graph to the right from interval 0 to 1. Which graph is growing the fastest? So let's look 0 to 1. All right. For s of x, at 0, we have 0, 0. And then at 1, We have 1 comma 2. So let's find the slope of s of x on 0 to 1. It'd be 2 minus 0, 1 minus 0. We get 2 over 1, which is just 2. So we know that s of x, its slope, equals 2. So now let's go ahead and find the slope of r of x. This also has a point at 0, 0. But then at 1, it's got 1 comma 1. So if we find the slope, we get 1 minus 0 over 1 minus 0. We get a slope of 1. So on that interval, which graph is growing the fastest? Well, r of x is growing, or oh my goodness, no it's not. S of x is growing the fastest because that has the largest slope. All right, largest rate of change. I guess actually that would be a better way to write that. Would be rate of change. Rate of change. All right. So let's go ahead. Now we're going to find the rate of change on another interval. It says from the interval 2 to 3, which graph is growing the fastest? So let's look at 2 to 3. So we'll go back to red for s of x. And on 2 to 3, we have a point here and a point here. So we've got 2 comma 4 and 3 comma 6. So we'll calculate that rate of change using the slope formula. So we get 6 minus 4 over 3 minus 2. We end up with a slope of 2, which makes sense because s of x is a linear function, which means it has a constant rate of change, which is the slope. Now let's find s of x, or I'm sorry, r of x. Oops. So for r of x, at x equals 2, we start off here. Then at s equals 3, we start off right here. So our point is 2 comma 3. Then we've got 3 comma 1, 2, 3, 4, 5, 6, 7. So now we can find the slope here. So we're going to do 7 minus 3 over 3 minus 2. We get 4 over 1. All right. And with that, we get a slope of 4. So on this interval, r of x is changing the fastest because it has the largest rate of change.